Oh, it's dance time.
It's dance time.
Is this the coding dance?
Well, we haven't gotten to the coding dance. This is just the intro dance.
This is the warm-up dance for the coding dance.
Hello, Dr. Barth.
Hello, Eric. How are you doing?
I'm really doing quite well. Aside from various insurrections and presidential changes and whatever, 2021's actually been pretty good to me so far. Yeah. How about yourself?
Oh, I'm doing pretty well. We tried a new pizza recipe this week. Yes, it was normally we just cook pizza, but we got a book called the Pizza Bible, and it had a 3-day pizza recipe in it. You make the dough one day, you put it in the fridge, then you take it out and you work with it a little bit, then you put it back in the fridge, and finally on day 3 is the time to actually cook the pizza.
Is there that goes along with the Pizza Bible?
Is there a what?
I don't know. Anyways, that's fantastic. How was the pizza?
Actually, really good. Turns out if you put more work into something, you get a better result. Who would have guessed?
Who would have guessed? I made bread for the first time in 2021 today. I got onto the pandemic sourdough thing last year, and but I restarted my bread machine. We had we had too long a story, but we had a disaster in our laundry room that locked me away from my giant vats of flour. So I couldn't bake for a while.
You finally cleared the debris, took out all the 2x4s, and just rediscovered your treasure trove of flour.
After removing gallons of water from the floor, I was able to get to the long story. Oh, wow. Anyways,
can
we talk about some code?
Yes, let's do some rubber duck engineering.
So we were talking in the green room, in the happy space before we pressed the live button about doing Boids tonight.
All right, Eric, what are Boids?
Well, I think we talked about this in Rubber Duck Engineering number 1 or number 2, if you might remember.
Oh, longtime viewers, we're finally going to pay off promises we made a long time ago.
You've invested in us, and now we're paying you off. So Boids are bird-like objects, I think is what it stands for. If you type BOIDS into your favorite search engine, you will find the Wikipedia on the topic.
So we're going to turn our sheep into birds? Are they going to fly?
Yes, we will have flying sheep or toasters or rabbits or something.
Are they rabbits, not sheep? I've been confused. They look like sheep to me. They're very sheep-shaped.
Oh, it's true. And they do have a sheep kind of color. I'd been referring to them as Wabbits in the tweets.
Okay. Wabbits, very good.
And of course, they're called prey in the code. But, that could work for sheep too. Anyway, so Boids Boids are interesting because you get this sort of emergent behavior from all of these individual actors with very simple rules, kind of like our game of life stuff that we were doing, and similar to what we were doing with this ecosystem stuff. So it's very on brand, I think, for Rubber Duck Engineering.
So what are the rules?
Well, we'd have to go pull up the Wikipedias, but I do have a Wikipedia machine. Here.
All good coding adventures start at Wikipedia, as far as I can tell.
That's probably true. We started at some random person's GIF decoder. Was it GIF? No, Wave decoder docs. Boids. Let's see. Press the right buttons so that the right things appear on screen. I was talking with a colleague at work today about our show, and they asked if we had a fancy setup to swap between cameras. I said, unfortunately, not yet. All right. But I do have a separate machine to do this. So, Boids. Artificial Life Program. Developed by Craig Reynolds. Craig Reynolds sounds famous. Boids. Okay, he just created Boids.
He worked on Tron and Batman Returns. That's cool.
Cool. That's more movies than I've worked on for sure. Oh, here, yeah. Yeah, I don't know if that's the best example. That's in 3D, clearly. There's little pyramids flying around. You can see how they can kind of flock. So anyways, Boids is this relatively simple algorithm that that each of the actors in your scene do. And then this emergent behavior comes. And you can use it for schools of fish or or sheep or birds or whatnot.
So I noticed that 3 of those rectangle or pyramids were red. Does that have a meaning that you're aware of?
It doesn't have a meaning to my knowledge. So I actually have done Boids in 2D in Flutter. And this was one of the things I was doing for fun right around the time when we started this show. I have never done Boids in 3D. I think maybe tonight we could do 2D or start with 2D.
Yeah, I feel like our sheep are mostly confined to the ground because that's where their food is.
Well, we also potentially could do this to like the wolves or whatever too. But I think it's interesting to think about sort of pack behavior. But it starts from these just very 3 simple behaviors of you look around to see if there are any other Boids that are near you, and you try and steer so that you'll be moving away from them. You try and align your forward facing vectors, and then you also average your like local collection of Boids, and you find the midpoint and you try and steer towards that. And I don't know this well enough to like teach a college course on it, but I have written my own Boids. I just watched a YouTube on it, and I like wrote it based on that. And so I think
is there like an equation in here, or they're just sort of general principles that you apply?
General principles. You can find lots of code on the web to do this kind of thing. But yeah, that's it.
All right, let's do it. That sounds like fun.
So let's find our code machine. So I think we don't actually need this. I don't know how to close it. You ever get that when like you have a window that's like hung off the side? You don't know how to actually, whatever, it's fine. Don't know how to actually get it back on screen. All right, anyway, so here's the code machine, except we actually want the Unity machine. Here's the Unity machine. And I think if we want to do this, we want to make a new scene so that we can mess around with the same code base in like a different scene.
All right.
I don't remember how to do that.
There's a plus sign right there. I don't know if that'll do it for you. I don't know. This is working inside the scene.
I totally see YouTubers do this all the time when they want to do exactly what we're doing.
Maybe it's an asset?
I know it is an asset. It shows up in your assets folder. Really?
We did it before. The breakout game was multi-scene.
But the part of the reason, because then you can like create a scene, you write a bunch of scripts for it, and you can chuck the scene. So like here is a scene, right? And we could just
Wow.
Right,
for some reason it was in one asset creation menu and not another.
Yeah, who knows? All right, so here we are. We're in our new scene. We could drop a new. We don't actually even need a ground object. We just make a. How do we make this smaller?
So doing like a Boid prefab with a script, is that where we're going?
I think I would add just like a sphere. Sure, which are like, actually we want it to be directional. Like, I think that's why you see the 3D object. What would be directional? Like a capsule?
Or a cylinder, yeah. Capsule or cylinder.
Cylinder? I don't know how to distort the mesh of a capsule, but that's fine, whatever. So we'll call this Boid.
Whoa, it became enormous. Enormous cylinder.
So we have our Boid, and we want to add a component new script called Boid. Who knows where to put it?
Let's drop it at the top level.
All right. So this probably isn't going to like end up in this thing, but we can start here. So I think we start by just having this thing move around in 2D.
Okay.
Right? So
Does it have like a velocity?
yeah, I think we could have like a float velocity, which is like its forward direction.
Mhm.
And so remember what it is? It's like transform.
Transform that position, I believe.
Transform
Translate.
right?
Translate. Sure, that'll do. So
Yeah.
like
Vector 3 dot forward times velocity
times time delta.
times time delta. And really, we should be doing this in the. That's fine. That's fine. So okay. So now we have a velocity, and this thing goes forward, and we can set this to. We don't need to.
Just make it public, right?
What's that?
I just made your velocity public, so you could set it in the editor.
What happens if we just play this?
I think velocity is 0, so I would expect it to.
I don't see it anywhere. Where is it in our scene?
Oh, it's in some weird place. You don't want to put it at 0.
No, let's see that. All right, so if we reset this to 0, we do see it now. Okay, so now if we set our Boids velocity, what is this? Why is it capsule collider in such a weird spot? Maybe that's where it should expect to be. I don't know.
You may have to go back to the editor. I may have made the velocity public in a way that
I have to save it in order to trigger the local. All right, so say velocity is 1. This thing should now just start moving when we play.
bye. The cylinder is receding into the distance.
Okay.
I guess I was expecting. Well, anyway, I when I thought about the cylinder being directional, I imagined its non-round axis, the elongated axis, as being its nose. But this works too.
We could potentially change that, but all right. So let's have a cube, or rather, this is our ground, so we can see the darn thing. Reset this again. Make it scale to be X and Y 10. And we'll move its Y to be, or its position to be like -1. Okay, so now if we hit play again.
Oh, bye cylinder.
Okay.
So do we go through the principles and implement each one?
I think so.
Okay.
I think that's. I was trying to think about like how do we make this not just like go off into infinity, but I think the part of the cohesion will do that. Like we don't have to like do collision avoidance or whatever because they're just going to find each other nearby and I mean this is like first principle Boid work which I guess we do on this channel as opposed to finding some code on the internet. So let's find our Boid again. We're going to end up. Oh, that was not what I wanted. We're going to end up wanting probably.
Are these like separate functions? Like in update, we first separate, then align, and then cohese, and then move. Is that how this goes? Or
I don't actually know. I'm trying to remember. I mean, I gotta go pull up the code as to how I did this before. Like, I don't know how you combine these. Do you just average them all together?
I see, because they're each everything is trying to steer.
I think you're going to end up getting, correct. They're all just trying to steer. You're going to end up getting I think you're going to end up getting basically 3 steering vectors out. And then you have to make some arbitrary choice as to how you weight them.
I think it'd be interesting just to do each one separately. Like, what if we just did the separation and we had
exactly.
a bunch of them, see them all scatter or whatever?
So the question is, how do we? So when I did this on a 2D surface, and I had them wrap. I mean, we can pretty easily add wrapping.
But
right?
we don't need to start there. I would just try to find the Boids in your local area, and then
all right. So you want to find. Okay, that's easy to do. And then what do you? And then
let's try to separate. Like, compute the separation steering. I'm just trying to make the like minimal. Like, what is the minimal step here to make progress?
Mm-hmm. I suspect this one is probably the easiest to do.
Okay, so let's start with that one.
Ask each for steering vectors, and then average. Right.
And then we need some sort of like rotation velocity, because I imagine we're not going to snap to it, right? We're going to like adjust it.
This is going to be vector 2, right? Because your rotation velocity is going to be. Oh, we're in just 2D coordinates, right? So you just have one.
Yeah, I think you just have one float, which is like your rotation speed or whatever.
Okay. Mm-hmm. So this is very easy. This is just game object.find by find. But we need to find nearby, like within a radius, which we did exactly.
We could just start by just finding them all and handle the radius as a refinement.
Well, I'm just saying we like.
Oh, we did this. Yeah.
We have this like exact code right in.
For the flocking, actually, for our previous concept of flocking.
This, right?
Yeah. I feel like this is n squared. Like, each one is going to iterate over all the other ones, but whatever. That's fine. Do we want it with a tag, or do we want it with a type? Like, find nearby.
Sure. Yeah, I don't even know that we need like a. I mean, well, you actually are going to want a tag, right? Because say you're running this, you're going to have multiple different separate Boids things going on, right? You're going to have the wolf thing
that's really that's a good point. Okay, so find them with the tabs closest. So I feel like we just want to have a array of nearby.
Mm-hmm. Yeah, so this actually returns app.
I'm going to make a new one of these things. How does invent it? Like, is that how you make a new array?
Seems reasonable to me. I don't see sharp, but
it seems it's underlined, so I imagine we need to put a number here.
Sorry,
size.
Our banner. That's all.
Do you want to research what a variable size array is like?
Sure. You mean like for collecting these?
Yeah, I want to collect them up, right? Like I want to see sharp. I want a list, apparently. List.
That makes sense.
Sure. These things like all exist in every language. They just have some
different
name. Yeah. Nearby.add.
Because we're going to want a radius on these things too, because you're going to want a search distance.
Current distance. Okay. Well,
you already have that, right? That's why we pulled this code.
Yeah, I think it's keeping track of like a min that I want to try to make sure we're not what I'm doing here. This distance value we don't care about. Right. It's just this.
Mm-hmm.
The current distance is less than the surface is, and find a winner.
Yep. Yep.
Mad about something. Oh, do I need more parentheses?
This requires
New list.
this. Does this need to get turned into an array, or do we just return the list?
I think we just work with the list, right? I think the list is probably, we could probably iterate over the list just as well as we can iterate over anything else.
Boids. And we'll call this Boid for now, and actually we just call it Prey because we already have that. And radius 5, whatever. Or actually, we'll do vision radius. Okay.
It's mad on my computer. I don't know if it's mad on your computer.
It's happy as a clam on my computer.
Okay, great.
All right, and so now we need to average steering vectors. So we have to like sum them all up. How do you average a bunch of vectors?
Can we read our own tag? Like, do we necessarily want to find the Boids tag, or can we find like game object?
Yeah, you can do that. Game object tag. Vectors unity. I see. You add them up.
Yeah.
Okay. All right, makes sense. So vector 3 average new vector 3 and for var void in nearby averaged what's going on?
For each rather than for in C#. Actually, I looked at the docs. For each is supposed to work with lists.
Oh. Find operands.
You want void, right? The void dot game object.
It's not even game object. It's void dot like transform dot for.
Oh, it is the game object.
Yeah. Okay. And then we're just doing, except this is actually a sum. We want vector 3 average.
Yeah, it has a list has a count property.
Sum x divided by
nearby. Oh, you can just. I'm sure you can just divide it.
Divide?
Like yeah, you can do a vectorized divide. C# is also like that.
It has operators. All right, so find nearby average surface. Okay, so this should be the alignment behavior. So this is like plan alignment. And this should then be vector 3.
We should pass in the list of Boids, right? Because we're only going to want to search once.
Yep. Okay, so vector 3 is alignment.
And then we want to rotate a little bit towards this.
And there's a way to do that. There's like a lerp angle, I think, on transform.
Hmm.
These are like common things to do.
Oh, mathf.lerp angle, is that what you're looking for?
Yeah, I think so. Just looking to see. Vector3.lerp.
Lerp angle, minimum angle, max angle. That gives you back a float.
Quaternion rotate towards. That's what you want.
Ooh, that looks good. Turning rate. Oh man, that's awesome.
Exactly.
Quaternions always pop up in this moment where like, I want to do something with angles. I don't quite get it, but like Quaternion will solve it for me.
It's exactly this commenter right now, right here. It's saying Euler angles, Euler angles are great for data entry, but terrible for interpolation. So it's like when you want to do math, you want to end up in quaternion space.
I know they're just slightly too awesome for my math brain to understand, but cool.
Something kind of like this in WebKit, where like whenever you wanted to actually do math inside the rendering tree, you like needed to get into like 3D coordinates or whatever the
homogeneous coordinates.
Yeah, you had to like move into a different space if you want to do math.
Well, my brain actually like I understand homogeneous coordinates. They actually make more sense to me than Euclidean coordinates. So homogeneous. I don't know if you're probably familiar with it, but just in case the viewers aren't, in Euclidean geometry you can have parallel lines. So lines either intersect or they're parallel, and if they're parallel, they never intersect. But in homogeneous coordinates, they're like, that's silly. All lines should intersect. And so if you would otherwise have parallel lines, they intersect at infinity. So if you imagine like looking down like a railroad track in perspective, the two rails of the railroad track are parallel, but off in the distance at the horizon at infinity, they intersect. And so it makes all the math really simple because you never have to have all these special cases for, well, what if they're parallel? It's like nothing's parallel. And it makes all these amazing things happen. Like, so you can model a translation just as a multiplication because you're just multiplying by some point at infinity. And so you try to like go over there to the point of infinity, and that just means you translate over like some parallel amount. So that's how this matrix, the transform matrix here, you can multiply it to apply a translation because the transform matrix we're working with is actually in homogeneous coordinates. I learned all this stuff way back in the day working on OpenGL. Because OpenGL
is
I used to write GPU drivers because OpenGL is all about homogeneous coordinates.
Okay, so we have our alignment, and we want to do transform dot rotate.
We need the quaternions.
Stop typing quaternion. Rotate towards from. Okay, that's going to be transform dot forward to,
which is vector 3 forward, right? Oh, I see.
Alignment. And then max degrees delta. This is going to be, so this is like rotation.
The example you had was really good. The example put in its velocity times the delta time. The turning rate. Okay, we should call our variable turning rate. That's an awesome name.
Okay. Turning rate times delta time.
I messed up. I renamed the wrong thing to turning rate. Oh, vision radius. Oh, okay, cool. No, I did the right thing. What is the vision radius?
Can't convert from, I think there are multiple of these. The vision radius, well, we have to have some radius that we're looking.
Oh, I see. That makes sense.
So when we typed rotate towards, it gave me options, didn't it? No, it's just the one.
Oh, quaternion from. We need to turn our vectors into quaternions.
This makes me feel like there must be like a helper that does this for you. But okay, I'm gonna look. I see transform dot rotation equals. problem with this approach.
Yeah, you just want transform dot rotation. Our current rotation.
I see.
Our target. We need to express our target in terms of a quaternion. So we have a vector.
Yeah, I mean, you can always do quaternion Euler, and that's the constructor that we'll take.
Oh, I see.
Euler. And this should just take a straight up vector, I think. Yeah.
Constructors.
So you just simply straight up do. So maybe this thing should return a quaternion instead.
Oh, that would make sense. Sure.
It's not clear to me. It's fine. We can just do. Let's see, because we have to figure out how we're going to be combining them, right? Euler. Right? Who knows?
Okay.
That should theoretically work. All right. So the other thing we need is a Boids spawner, because we want to like smush out a whole bunch of these.
Right, and we want to smush them out like at random angles and locations.
Yeah, exactly. So I think if we add a new empty, we'll name this Boids spawner, and
we also need to tag the Boid and make it a pre-built.
Yep. What did we tag it? Prey?
Sure.
Oh, it doesn't actually matter. It just needs a tag, right? The way we wrote it. Okay, there's our Boid. We can actually delete that. And our Boid spawner. We add component. So what we're actually doing, maybe the viewers have already figured this out, is that like you and I are learning how to do these basic things in Unity by now doing them for the 5th time.
Yeah, well, repetition does not spoil the prayer, as they say.
I mean, we're way better at this than we were the last few times. Still feel terrible, but way better. Okay.
I think when I learned by just like slamming my head against a thing over and over again, I learned it in a different way than I would learn it in other settings. It's like it becomes more visceral somehow.
I feel like this is the only way I learn. It's just do. Okay, so we have our Boid spawner.
So we need the public prefab, right?
Yep. And then I'm just gonna actually just steal some of our code from our spawner because we do this all the time. Doesn't really matter that we were.
We wanted a random, random on unit circle or something, right?
I don't know what this does. This does look at. Like we don't actually want it. We just want it random along Y. You want like vector 3 top times random.value.
Random Y.
Right, because we're only rotating around one axis in our world.
Oh, that's a really good point.
Right. So I think you want vector 3 dot top, because that's the unit vector that's pointing out the top.
Up, right?
Up, sorry, yeah. Times random.value. Lowercase value, isn't it? Yeah. Because Unity. I actually don't know why.
That doesn't. That's only going to go from 0 to 1, right? We want to go to.
Does it? I see. Well, you just have to multiply it by your. You just multiply it by 360.
Mm-hmm.
Are you doing it?
Go for it.
So this is not needed. None of this is needed. Theoretically?
Yep. I think this is okay. I think that this means we need this map size.
That's fine. We'll just throw it in here. Float. Public float map size equals 10.
Yeah, I think if we go over here to our Boid, then this Euler alignment thing is not correct.
If we look at our Boid.
But basically, I think our plan alignment, we went to vectors too fast. Instead of getting transformed out forward, we should have gotten transformed out rotation. And our sum should be a quaternion. Right? And then we can average the quaternions to get an average quaternion. Then we can return that. And then that we can feed in.
Well, we also could just have an average of floats, right? Because as we just established, we are not operating in any vector. Like we have 1 degree of rotational freedom here.
That's fine, but we're okay. But this code also looks nice and clean to me.
It
doesn't compile, but it's otherwise beautiful. Maybe we want to flock in 3D. Who knows?
Yeah, no, I just think that would be fun to get to that rotation. Oh, you can't plus equals a quaternion.
Okay, so how do you average quaternions?
You're looking
See what I'm saying? Like we jump to vectors and then
I hear you. I don't know with whether what you're saying makes.
Oh, you can totally lerp quaternions. That averages 2 quaternions.
I love some of the commenters on Stack Overflow. They get on their high horse to explain. What?
Is it not a thing? Is averaging quaternions a terrible idea?
There are clearly people who have these things, but why do I?
Oh, I see. You just add it up. You got to use a slurp. What? How is it a circular lerp?
What?
Yeah, you do this. This is great.
Okay, show me. Teach me, Obi-Wan. Hold on, I want to be here. Slurp?
Slurp.
Is this like an average or something?
Yeah. I think it's a spherical lerp.
What does that even mean?
Okay, here's our Stack Overflow code that we're going to beautifully adapt. So our average is going to be, we have this nice 0 quaternion.
Okay. Or just identity or just quaternion empty, I suspect is 0.
Amount. I'm going to guess this is an int, a float. That code does not really compile. But it's okay.
No, it didn't make any sense.
Amount plus equals 1.0f. And then we're going to lerp it in.
What are you doing?
It makes sense. It makes crazy kind of sense. Average. Void, transfer verification. 1 divided by the amount. As you go, you factor it in less and less. You slurp it in less and less.
I see. This is like a rolling average.
Yeah, it's like exactly. So the first one goes in 100%. So your 0 gets erased right away.
Okay.
Your second one in goes in 50%. So now you got to mix it 50%, 50%.
Okay.
Yeah, it makes sense.
Okay. I wonder how many cores, how many GPUs we need to do this. lurking average of quaternions.
Why not? Someday I will understand quaternions, and it will be a happy day.
Okay.
You know what the biggest problem? But what's going to happen is we're going to have all these cylinders that are all going to rotate, and we're not going to know.
Why not?
Because they're spherically symmetric, or they're circularly symmetric about this axis.
Yeah, fine. So we'll make them cubes instead.
I think we just give them a nose in the prefab.
Sure, we can give them a nose. We can change the prefab. That's the whole separation of prefabs and encode here. So we need to do a bunch of these for int I equals 0, I less than 10, I plus plus. We need to spawn them in different speeds. Are they all the same speed? I think they're just all the same speed for now.
I think it's fine.
All right, so this should spawn 10.
And they should subtly align themselves, and we won't be able to tell.
Well, we should, because they're moving forward, right? So we should be able to see their...
Oh, that's a good point.
Oh, we haven't assigned. Boid prefab. This whole being skewed by half an hour is really messing with my mind. An hour is just never enough time to actually get a lot of code written. Variable void prefab void spawner has not been assigned. I just did that. What did I do? Oh, I bet I assigned it while it was going. Thank you, Unity. I love you too.
Something is happening.
I'm not sure something's happening.
I mean, they're moving around.
I want to change this to be position Y 30 Z 0 patient around
X.
X, is it 90?
Okay.
And then we can probably actually make this 20. 10, fine, 10. I don't see any aligning here. Not sure we're slurping. Are we even using this? I mean, we just have to debug. Like, we have no idea what's going on here.
Can we take out the translation for now and just give them some indication of what their rotations are?
Sure. So we could do that. There's a whole bunch of things. We could just do debug.draw line. Do we draw array? Transform.position to transform.position plus transform.forward. I bet there's a simpler that draw array does this easier.
Yeah, draw array looks like what you want.
Yeah. I want transform.forward. Color.red. Want site. What did I call it? Site radius? Vision radius? So that should show up, at least if we show gizmos, which I think we have. I don't see it. Why am I not seeing it? Gizmos.
Okay. They're not aligning.
I blame the slurp.
So we can always just return the first one. Oh no, their vision radius is too small. Like if the length of that ray is their vision radius, they can't see each other.
Yep. That is correct. But also, why is it like it doesn't look like it's coming from their center? Something looks. Oh, I guess we're looking. It is coming from their center. It's just coming from the bottom of the cube.
Oh, I see.
Or the bottom of the thing, and our camera's kind of close. These are kind of tall. Wow, so our vision radius is really small. Let's see, Boyd.
Well, zero. Zero is pretty small.
Rate is also not going to help.
we have many problems with zeros.
Okay, so this. So that should make them turn 30 degrees a second.
Mm-hmm.
And that's a vision radius of 10. So they should probably all be able to see each other.
Oh, well, you did that in play mode, so it might not have saved. That's it did save. That's a very funny feature. I don't fully understand it.
It does seem to save when you edit prefabs. Whoa.
Whoa. It worked.
That's weird.
How do you undraw rays?
Yeah, I would have expected those to go away. I bet draw ray is like creating a new game object. I don't know. There's probably someone watching this has some idea how Unity works. And
well, should we turn the translation back on? Otherwise, we won't be able to see what.
We are so addicted to CodeTown, by the way. Like we keep going and recompiling, and whereas we could have just edited the prefab to like turn the translation speed off.
Oh my gosh!
Oh.
they aligned. That's so cool.
And they go off into the distance.
Bye bye. Nice to see you, Boids.
Okay.
Should we do the next principle? Like I feel like we nailed that one.
We
nailed it.
Time. We have like 9 minutes.
Oh, okay.
We might not actually get a second principle done. Steer to avoid crowding local flock mates.
Oh, we did cohesion. Steer to move towards the average position of the local flock mates. That's very similar to what we just did.
Okay. Plan cohesion. Spell it right? Or the guy in there?
So now we want to find their average location, right? 3.
Yep. Oh, it's basically the previous code again.
Right, but we can actually just use the code that we deleted, sadly.
It's okay.
Is void dot. Oops. It's a funny, like autocomplete. I don't know why.
So entertainingly, I was looking at so we run these user surveys in Flutterland, and I was looking at the user survey from Q4, and there'll be a blog post about it soon coming to the public. But it was talking about, there were a lot of complaints about autocomplete, and I was really surprised by that. Because my experience with Dart autocomplete is it's really good. I find IntelliSense really frustrating. But something to learn about. Anyways, that just reminded me of that.
So I think average is their average location, and we want to make a quaternion from where we are to there. Like we have our position.
Yeah, this is like lerp, right? It's just like the turn rotate towards, right?
Well, rotate towards is taking in quaternions. I need to get into. I have 2 vectors, and I want to get the rotation from one to the other. Or the.
I mean, okay.
Equals average minus. I have this delta, and I want to get a quaternion out of it.
I mean, oh, I see. This is sine or cosine, isn't it?
I don't know. Quaternions blow my mind.
Well, but if you want to get into angles, you currently have lengths, right, from your vector.
Mm-hmm.
And so isn't that exactly what sine and cosine do? Or
I guess. What do we type? How do we do it?
years ago for me.
Look rotation. That's what we want.
Sure.
Quaternion dot look rotation. I think the direction to look in. Yeah, look rotation. That.
Okay. Dot, yeah. We'll try.
Yeah, I just feel like we should just try to only do that and see what happens.
Okay. Okay, we're gonna press play. Let's compile.
They're.
I mean, they seem to be collapsing on one another.
Oh wow, that's kind of cool.
I think it's working.
I guess what's happening is their velocity is greater than their turning speed, so
they can only turn 30 degrees in a second, which is slow. Right? If we upped their turning rate to say 90, that won't actually do anything because I just edited the prefab. I would have to edit the. So now they'll
actually succeed in coalescing.
Mm-hmm.
That's neat. I guess they can't stick together because even if they're really close to each other, they got to keep moving. So they're going to have some sort of.
Add them both.
Yeah. Okay. Let's try to add them both. So I imagine we're going to slurp, right?
Sure, and we can just do 50-50.
50-50.
50-50.
Or cohesion. F's. So many F's.
Okay.
What you had in mind?
Yeah. Let's try it. Oh, unknown. This behavior is missing. I don't know what that meant, but so now they're trying to align and
yeah, which is what they did. They all aligned to fly that way, and they got really close to each other.
Yeah, and now we just have to add in the avoidance. So there's some clear, obvious little fixes we could do. Like we could make them much easier to see. In our next episode, we can add the last behavior. But I think this is great.
Yeah, I mean, I feel like they're not fully flocking, but it makes sense because we only did 2 out of the 3 rules. But it seems like they're doing sort of neat move around kind of stuff. So cool.
I love this kind of problem where we get to sort of implement from first principles and do it wrong in our own voice in our own code.
Yeah, I'm sure we totally messed it up some way, but like at least it's doing something.
So I forgot to mention at the top of the show, we moved back a half an hour as we announced we would last week. It helps those of us who get up really early like me to be able to go to bed at a reasonable hour. So this was great, Dr. Barth. It was fantastic to play with some Boids with you. Do you have any further notes for our friends on the interwebs? It looks like 2 folks are watching right now.
Oh, welcome. You all should comment in the chat and tell us what you think. But yeah, I think tune in next week at this new time, and we will add the third behavior, and then apply it back to our sheep/rabbit simulation.
All right. See you next Thursday, 7:30.
See ya.